Let's start. Today, I am going to talk about partitioning. So, many times while the system designings, engineers are talking, hey, here we can need to partitioning. So, let's understand the partitioning, uh, meaning of partitioning, understand the concept with respect to the system design. While the system design, what is the meaning of partitioning and what are the different way to do the partitioning. So partitioning uh, is a technique in a system design where the large data set or the complex system is divided into the smaller independent and more manageable parts. That's called partition. So as a literal meaning, partitioning is just making a partition, making divide them in the parts. Okay, so same meaning here. Partitioning means when your data set is going to the large, so or any complex system, you are just going to divide those in smaller, independent and more manageable parts. So each part known as a partition, and each partition can be processed, stored, excuse me, sorry. So each partition can be processed, can be stored, can be accessed independently. In this way, what is the objective? To improve the overall performance, scalability, and maintainability of the system. So partitioning help us to design a system that are meet the improve the performance and increase the scalability, and your application, your system become a more maintainable because you are making your larger data set into the smaller part, and that each parts are independent. Basically, might be you have observed in the database. Let's you are running one query from the particular table. Okay, if the particular table have some set of rows, if I have some limited rows, our query are quickly response first. Select name from employee table. If employee have a limited records, our record. But what happens? One table contains millions, billions of records. So in the same table, you now go run the same query. Select a name from table with something this. You are observing your query get larger time to response because now your data set is very large, and this large data set running the query take response very larger than expected. The objective of here, whenever your data set is going to become a large, a particular uh, cross the limit, and that what happened, why not we break in the independent table. Let's table 1 and table 2. So if your table have a small data set, the same query quickly responds, same query quickly responds. The objective of the partitioning is that you can store data in the different table or different database or different schema, so that when you need to fire the select query, get the query at that times, you are getting quick response. So partitioning help us to response data as quick, because the objective is that let's say one customers are sending us some data, and we as a system, our system are storing. That's a good part. This is the one part where, but later part customer can ask, hey, can you give me all the particular calls from the 1 month to 2 month, or was the success ratio, failure ratio of any, let's say in the telecom domains. So in telecom domains, minutes, every minutes, thousands of calls is going on. Every calls are going to record it, CDR, call detail records, and later part network providers or whatever they called service provider, they are interested to find out some statistics from the his call. So in this case, they are going to run the query. So that means ki once your data is stored in a system, after that our customers requirement is do the analytics. For analytics, they run the lots of query. Our query response is so late, that's not as expected of any customer. So this partitioning help us to improve the data read operations. Okay, so in the partitioning, these are the some basics concepts. Like whenever you are going to, hey, this is the large data set and huge millions of records in the one table you are put. Okay, that's great. But question is that how I am going to partitioning in the table. So we need some kind of a partitioning key, on which key basis I am going to partition. So partitioning key is a unique identifier that determine how data divided into the partition. It is used to map the specific partition. So here let's you say, hey, this is my larger data set. I am going to divide into the four parts. Okay, these are four parts. So which data going to the which part? 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 So if each partitions we have a specific key. So on the basis of if any data come, that's go. So simple ways partition key, maybe we are maybe the department wise. Hey, this is the health department, put data here. Here maybe your uh, security department, put here. Financial department, put here. Inventory, put here. So maybe you have to decide different kind of a what are the your needs, on which basis you are going to divide this data. So partitioning key help us to decide on which attributes of my data, on those basis we are going to partition the data. Second, partition schema. Partition schema define the how data partition, such as a range base, hash base, and list base. So lots of partitioning algorithms or schema are technically available in Google Docs. And also we have to discuss. So what would be the size? That means if we decided, hey, this is a partition one, partition two. So each partition, how much data they are going to hold. So we have to decide the size of each partition, which can affect the performance and storage requirements. Okay, so this is the major things. You do partition, that's good, but we have also defined the size, the how much record or data this one partition going to store. If you are not deciding, still data growing, you are reach the same stage. Our particular partition have a larger data set. Again, our performance of the system going to degrade. So partitioning key is also important, and after that, partitioning size is very important. You must define how much data one partition can hold. These are the basic kind of subsystems in this partition. Whenever you are going to do, okay. So generally, one would be the partition manager, that is responsible for managing the partition and handling requests and directing data to the correct partition. So whenever you decided, hey, this is my different partition, partition one, partition two, partition three. So one need be some partition manager. Okay. Any data come, hey, this is the data come. So this partition manager decide, hey, this data go to the specific partition. A new request come, okay, this data going to the again the same partition. This new request come, hey, this data go to the next partition. So partition manager is responsible to know which data are going to store or which partition, or maybe particular request come, hey, request come. So partition manager know these requests are going to serve by the partition 1 or partition 2, partition 3 or partition 4. So partition manager is the responsible to routing the request to a specific partition, right? Second is the partition storage. Partition storage, they store the partition data, which could be a database, could be a file system, could be other storage solution. So here, so one partition manager, you have decided, hey, this is a partition manager. So they decided they are going to the store, so particular partition. The partition can be our database, can be a file system, can be any other storage solution, whatever you have. So here partition is not specific to database, but maybe let's say, hey, customers are uploading the images, photos. So photos are going to store not in the database, generally in a file system. Yeah, block storage. Let's say customers on the, let's say on a YouTube or Instagram, millions of people are uploading videos. So videos is not like a data database. Videos can be stored in a separate file system, separate directory, some separate store block. The nature of the data, we, our partition manager is directing to store data on the maybe database, maybe file system, maybe any other storage solution, whatever kind of data, like video data, audio data, image data, photograph, text based data, code based data. That for nowadays, nature of data, nature of storage devices we have to use them. And second is your client. So generally the partition architecture look like, hey, this is my or partition manager, and this is the client which generate data, and partition manager, hey, send, this is the partition 1, partition 2, and partition 3, and partition 4. So whatever the respective data they are here, partition manager communicate. So this is a very high level architecture. Client interact always with the partition manager, because lots of partition, client cannot know which partition I am going to get my data, where my data is stored. Partition manager responsible to know, hey, the particular client requests are going to serve by the partition number 3, or partition number 4, or partition number 5, whatever the partition. So one is the client, one is the partition manager, one is the your partition storage, database file system, where the actual data are stored. So this is a very high level architectures of the partition. Okay, and this is the technique, the methodology or algorithms are technique available through which the larger data set, whatever the larger data set we have, okay, and the different attribute based, different category based, different techniques available to partition this. Partition is one or three sections. So here I am partitioning section 1, section 2, section 3. So on which basis I am going to, so these are some techniques available that help us, hey, you can partition. One is horizontal partition. This is sometimes known as a sharding. Sharding also we have discussed in the one session. Similarly, vertical partition, range-based partitioning, hash-based partitioning, list-based partitioning, and composite partitioning. So there are a couple of techniques we have, and we should aware these partitioning technique, so that we depend upon our use case, our scenario, we are going to use these partitioning techniques to partition our large data set. So let's talk about this one by one. So horizontal partitioning, also known as a sharding. The first sharding we have already discussed detail in the particular class. Maybe if you want to make detail about the sharding you can look. But here I am going to just brief what is the horizontal sharding, or also known as a partition. So this is a technique distribute large data set into across the multiple server or node. So here, this is the one by data storage, and this is the objective. I can add one more server and more server and more server. Physically, they are going to add more server. This is the not a look like a partitioning, but here say कि data are going to store in the multiple server, multiple database, multiple file system, different location, different geographical location, different attribute. So this objective say whatever the data, not store just one server. Instead, we are going to store multiple nodes as server. This is known as a horizontally partition. Means adding more node, adding more node, adding more node, adding more node. This is the basic concept of the horizontal uh, partitioning. And each nodes are the server is responsible to for a subset of overall data is called SAR. So here customer have a large data set. So some set of data are stored in this one server. Some portion of data is stored in this another server. Some portion of data is stored in the another node. So here the same data are not stored in the every server. Instead, subset of data is stored in the one node, another set, another node, another set, another node. So this is the way you can partition your data horizontally. And horizontally partitioning, also known as sharding, is a horizontal partitioning schema where the data is divided into the smaller independent piece called shard based on the partitioning key. And everywhere you have to decide which key on which maybe you are going to decide. So next is the vertical partition. So vertical partitioning is the technique used to divide large data into the smaller independent pieces called the partitions based on the common column attributes or schema basis. Here say, so let's decide here particular name, age, address. I am going to put in the separate table, and particular detail, other detail in a separate table in the, because the we are going to store data in the column basis, so that the particular data are frequently used. The specific columns they have going to read a small data set and all the columns. So column based are attributes based, any attributes based are schema based. So each partition are contain subset of the column or attribute from the original data set, and the partitions are typically stored in the stored separately, right? And vertical partitioning, also known as a column-based partitioning or attribute-based partitioning. So vertical partitioning also says this is a column-based partitioning or attribute-based partitioning. So here, simply say horizontal-based partitioning. You see, we are putting data in the different node. Here, say no, we are putting maybe data same node, but this is the column is column 1 in the separate table, column 2 in the separate table, yeah, column 2 and 3 in the one table, column 3, 4 in the separate table. And this is the range-based partitioning as well as. What is the range-based partitioning? Range-based partitioning is a technique divide the large data set to the smaller and independent pieces called partition based on the range of value. So here say let's key employee ID. Yeah, employee ID from 100 to 1000. I am going to store in partition 1. Again 1000 to 1 to maybe 2000 till partition 2, maybe 2000 to 1 to 2003 in partition 3. So in this way you have to decide any IDs of employee come under a particular data come under go to this. So here maybe here again range can be your name base, age base, sex base, geographical location base. You can decide range. So each partition is the subset data store fall in a specific range. That's stored. Range can be your range can be date, range can be number, range can be string, anything. Okay, so it might be many places we have developed system. Hey, whatever the data come under this month, go to this table. For this month, go to this table. For this month, go to the month wise or year wise or week wise. You can store data in a separate table. This is the logically you partition data on the basis of date or on the number or the particular maybe customer base. Hey, because the particular region base. Hey, the particular all the calls come from this region or go to the store in the particular database. This region come into this table. This region come into this table. The call base, customer base, tenant base, date base, number. So lots of things we are mentioned. The range based partitioning, also known as a interval based partitioning or value based partitioning, right? Some way is the hash based partitioning. Hash based partition also same as a technique that divide large data set into the smaller independent pieces called the partition, and each partition contains the subset of data determined by the hash function. map data to the partition. So hash function like in a one function, one function, one function. This is a one function. Whenever we pass x input data, they returns what the number. The let's keep pass the key one. So they return one hash value. So accordingly, hash value we are determining the partition. Many places hash based partitioning is very helpful. Hash is a function. Let's get you have decided ki I am going to store data in the 10 partition, 10 partition. So whatever the data I have come, I am going to apply hash function with a hash function with a we have a 10 partition. We have a 10 partition. So we have to just simple modulo 10 of those, convert all the data into the particular number system and modulo 10, and they return the one number. So you decide, hey, this is the input data. I am going to use the particular this partition. Next data come, convert to the number, apply the hashing function modulo 10, and figure out, hey, this is the might be. So in this way, you can say hash based function say maybe number, convert our request to the number, and on those number just modulo the number of partitions you have, 10 partition modulo 10, and you find the particular partition number where you're going to store data. So in this way, many places hash-based partitioning fit, and hash-based partitioning is also known as hash partitioning or hash-based sharding as well. So many places hash-based partitionings are used. They are very unique solution, and very can say manageable, and everyone since college times, since school times, we study this hash function. Any function, any function, hash function nothing is a mathematical function. Mathematical function say, hey, f of x, you can pass any x number, they returns your y value. Okay, this is a simple hash function. And hash function, this function we study since our schooling time, college time. So due to that, lots of variety of hashing functions, hash functions are used. Many hash base API available, has table available, and each and every programming language use the hashing, because this is a very mathematical fun concept, and everyone is aware that due to that, say whatever the input you can pass, I can give the particular number. So whatever the input we have, this is the one string come the key. I pass key, they returns one specific, maybe your function returns the some mathematical number. In mathematical number, you can just your partition those with the number of size of a partition. If partition size 10, they generate your unique partition, and in this partition you are going to put data. Similarly, new data, new key come, apply the hash function, generate the number modulo 10, and find the next partition number. So in this way, you can say we can find the specific partition for the specific data. So just apply one hash function, they returns one number. You can in this number you can modulo with a partition size, and they returns always the one number that would be your less than or equal to your partition size, and you can always direct your code to the data in the particular partition, right? So this is the hash based partitioning, is very simple, very useful, many places we are doing. Okay. Hash based partition. Okay. So here, next is the list-based partitioning. Many places. This is also one of the techniques that divide the large data set into the smaller and independent piece called the partition. And each partition store the subset of data. That's okay. Determined by the list of value. So here you can say, hey, I can say this is a list of IP addresses, and any data come from this IP address. I can go to the this partition. The partition manager know, hey, this is a list of IP. This is a list of IP mapped to the partition one. This is the list of email address. They are mapped to the partition this. Yeah, this is the list of region. This is a list of city. For this city data, go to the here. Yeah, this is the list of specific locations data go to the. So here, whatever the list of value, you can decide. List of value may be IP address, or a particular date, a particular city, particular region, particular department. A department one and two go to this partition. Department three, a particular any kind of value. So list-based partitioning also uh, based on the value basis. Whatever the value, you have to just tell, hey, partition manager, this is the list of value. And these are mapped to the partition 2. These are mapped to the partition 3. So in this way, list-based partition, many places like, hey, we are going to the implement the some blacklisting feature listing. So let's say, hey, I am going to find out these are the IP address for they are finding some details. So the list can be IP address, list can be date, list can be anything. And accordingly, specific data you can find. Hey, these are the list of IP address data with something that can be treated and handled separately, right? And least but not you can say last one, but this is a composite. But notice there are lots of technique on the custom basis, on your nature of databases. You can divide what kind of data you receive and just analyze the data, all the attributes, and you can decide which attributes, combination of attributes, or a particular timing data. That is nature of data. You can decide your partitioning size. So here composite techniques simply say, hey, we can simply say combining the multiple partitioning schema. Maybe you can combine month plus your list value, month, maybe vertical partitioning plus your range base. You can combine. So here, such as a range base or hash base function, you can just composite them and make some new partition. This just make openness to customize what kind of partitioning you want. You can make your own technique. This is also known as a hybrid partitioning. Known as a hybrid partitioning or combined partitioning. Whatever, yeah, composite partitioning. The purpose is that the nature of data you're receiving, you analyze your data attributes and decide which are the possible best way to partition my data. This is known as a hybrid, yeah, multi-value or composite partitioning. So good options, whatever the techniques and algorithms we have studied, for these already lots of technology available for the system. As a system design engineer, if we aware this technique and we have already open source and cloud-based solution available, whatever the generally for the database, generally we are not developing database, we are just using the database. Similarly, storage system, block storage system, huge images, a video storage system. Generally, we are using maybe cloud provider or some open source cloud technology. So in those scenario, we have to just tell them, ask them, or configure them such kind of data partitioning I want, and each and every software allow to configure your partitioning, your sharding, your replication technique, everything. So we keep in mind as a system engineer, whatever the things we studied, like replication, partitioning, sharding, these are you are not going to build from scratch. The lots of already technology available. We as a system design engineer, our responsibility, we have to know for this kind of partitioning, this kind of nature of data, which database, which technology, which file storage are helpful us. For if the distributed database you required, you can go Apache, Cassandra, Apache, SBase, Google, and Google, Amazon, everyone offer. If you're deciding, hey, this is the NoSQL database kind of thing, so you can go the most MongoDB, Amazon DynamoDB, lots of things. You need a cloud storage, so you can go maybe Amazon S3 or maybe Google Cloud Storage, Microsoft Blob Storage. They provide all kind of your partitioning, sharding, replication. They are related terminology. You can talk the replication, you talk the sharding, you talk the partitioning, and they are all these features your cloud provided services offer. Just you have to configure your Amazon S3. We need a five kind of replication factor, partition size X amount, and starting this way, they will suppose us lots of uh, library available, even a partitioning library available like Apache Hive, Apache Spark, lots of technology available. We as a system design engineer, our responsibility, we should on the top of the technology available in the system design concepts. For system design concept, first we know what are the replication, what are the sharding, what are the partitioning, right now these are technology, and after that you know the technologies, so that you aware, hey, for this scenario I'm going to decide a distributed database, and this is the my Apache Cassandra would be the fit, because these we know the benefit advantage architecture of Apache Cassandra as well as. So let's understand these are the two very common terminology like sharding and partition. So I'm going to talk a little bit about this. Many times our initial system design engineer are confused where I am going to apply partitioning concept, where what do you mean by the sharding. Sometimes we are interchangeable using, because partitioning, if you are going to the partitioning as a horizontal partitioning, this is become a sharding as well. Due to that, this is the confusion, because these two are related but distinct concept and the data management industry. Both are directly related to the data management. Here, data can be text-based data, audio data, video data, image data, feed, anything. Data can be anything. So those data management means data storage and data retrieval. So storage and retrievals are the key characteristics of data management. These two, partitioning and sharding, both are related to the data management one. So both techniques are used to dividing the large data set into the smaller, more manageable piece, but they have a different purpose and have a different implication. So I'm going to talk a little bit so that while you should aware, hey, this is the things partitioning, this is the thing sharding. So let's talk. So basic definition, if you talk about the partitioning and the sharding. So partitioning is a technique that divide the large data set into the smaller and more manageable piece called the partitioning, right? And that is in the generally in the single database or storage. So one database, and you can multiple table, multiple schema, multiple data set, you can go. If you talk about the relational database or MongoDB, they have different collections. Similarly, in a one MySQL, you install one MySQL database server, and one database server, you can install multiple table database, maybe one product database, one is the inventory, one is the shipping, one is the payment, and each database is different table. So this technique is generally uh, depend upon the one source of data, one database at the order. This sorting is also known as discussed horizontal partitioning, also known as sorting. So here technique to distribute the large data set into the multiple independent database and storage. So here say we are going to talk in the multiple independent data storage, multiple database, different server, different node. So the major difference is here we are going to managing data in a one database software, and that have a different logically divided data, partition data, so that we meet the performance as quickly. But here objective is the data are stored not in the only one but different server, different node. So here multiples database stock. Sorting is basically adding more and more servers. Here partitioning is only one server, and logically data are partitioning in different database and different tables. And let's talk often used to. The generally partition used to improve the query by reducing the amount of data to a scan. So here, if your table is very big, so our select query is very tactile because they have to read scan every row depend upon the, let's you say, hey, select star from table where department this and this, these conditions where clause are going to filter each and every row, and those row match our criteria they return. If your data set is very large, our query become a bottleneck. So do that partitioning help us to improve our query performance. Here say scale out database to to handle large amount of data storage and high traffic. So here let's key high number of volumes data are increasing. So instead of storing everything in one database, you can store multiple databases, multiple email locations, so that data is the distributed. This is a simplify the data management task like backup, indexing, restore. Here the improve the performance by distributing load across the multiple server. This month for starting say, hey, I'm going to distribute load on the different server. Each server is perform the test output, right? Each server have a different. So here they are routing load to the different database server. Here data come on the one server, and we are try to improve our query performance with the different techniques, right? Here increase the storage efficiency by allowing more in the storage location. So inside might be you can increase RAM, increase memory, increase file system, but here increase availability, just allow add more sort and more sort. So this is the key differences you can say between the both partitioning and sorting. Partitioning occur on the, as you discuss, the single database or single server. So whatever server means one node or one server. And notice, please be, whenever say single database means let's key in a one machine, you install the MySQL server. So this is the one machine you install MySQL server. In one MySQL server, you can create a multiple database. Database one, database two, database three. Each database we have a multiple table. Okay, multiple table. So table level, database level, data is divided, right? So sorting is involved the multiples independent data storage. Here say not this only one server. This is a different machine, node 1, node 2, node 3, node 4, node 5. The partition is basically focused on the only one server that is more performant. I hear starting say, I am going to add more and more server so that our high user traffic can be distributed different node, and in this way we can improve the performance, right? So you can say sorting is a very bigger level. Partitioning is very one specific sort. You can say you want to each sort would be more performant. So the sorting, okay. So partitioning is primary focus to improve the query. Here, sorting is primary focus to scale out as more server, and improve the read, write, and read operations because they are distributed user traffic to the different servers. Partition typically stored the same storage location, same database, or same instances. Sorting is generally stored in a separate volume, separate server, separate databases. And even you can say data can be retrieved from the multiple partitioning a single query because this is the only one server, this is the only one server, and multiple database, multiple. So here, in a particular, let's particular one database, you can multiple table one, table two, table three, table four. So you can one query can data get from the multiple table. So here, from the developer perspective, and here a retrieval data from the multiple sort, we have to add more complexity, and the you have to different complex technique we have to figure out, take data from the multiple sort. Okay, because these sorts are independently different location, different server. I want to get data from the multiple server, that is added some more complexity. But here in the partition data, the different tables, we can get simply with a complex a query with the simplest manner. Here, data consistency is typically data is more consistent because this is the only one server. All the data are properly consistent. Here, data consistency can be challenged to maintain the. Here, data consistency have a challenge to manage how to meet the each data are stored properly because they are different networks. Here networks involved, different involved, networks latency latencyy involved. So due to that, so we have to more partitioning system are more data cut consistency. Here is the data consistency is the some level of issue. Partitioning may be required the repartitioning because when data set grow, hey, one time you partition it. After that, you decide, hey, we have partition data, okay, in the different table, and you decided again this table is going to very large data grow. So we can say again partitioning required. Again, you partition a different chapter. So one partition once data grow and partition size meet, again you need to partition. Again you need to partition. But here in the case of sorting generally we just scale horizontally. We can add more server, we can add more server, we can add more server. So question is that when use to which one? So generally we have a large data set, need to broken into the smaller and more manageable piece, and maybe you need to improve the query performance and the data management with a single data storage. And when you want to data simplify the data management tasks like backup, recovery, index, so in this scenario generally we are using the partitioning. Starting, you can say very large data set that exceed the capacity of single storage. When the one server is not able to manage those data, then we come a sharding. So we have a one node, then add another node, another server. They are scale out the storage system to handle high traffic and large amount. Whenever your high number of volume, high number of data coming, the sharding is the technique help us. And you want to improve the right performance for the distributed system and load. Okay, so in short, you can try to say first, always whenever your data coming, and if one database server is able to manage your performance criteria with the help of partitioning, that's great. Still your system is receiving more and more and more and more requests, and one server is not able to meet the effective data management process, then we can go to the sharding. Sharding say, hey, this is the one server is not able to manage, let's add one more server, let's add one more server, let's add one more server. So sharding is the one more level. Now each shard you can apply the technique of partitioning to improve your data management function like write and read. So he can say bigger terminology, sharding and partitioning are not independently, but both are the separate view. Okay, so sharding is a different server, database server, data storage locations, and each data storage location you want to make more efficient, more effective, more high performant query, then you apply the partitioning. So partitioning and sorting is not look like the theoretical same, but the broader terms is the this look like a same thing. That's it, right? So our objective is that whatever we have to use. So let's talk about the some examples here. So database that is to scale data, for example, retail company might partition data in the region base, and region data are stored by separate partition. That's good. And maybe social media platform that might be partition can use where the country base and country data is stored in the separate country partition. But sometime whenever you now this, until your system is not so broadly with a high large volumes traffics data, your partitioning is okay. But let's your one database server, you did all the partitioning techniques, partition table, apply lots of hashing function, still our systems, because this is the one server, is if still system is seeing more and more and more and more data. So those scenario, you need to scale more server, more server, more server. That means scale out more horizontally partition means we adding more database server, more database server. So generally all the larger whatever the application, large e-commerce application, large online gaming, large social media applications, all are the example where you can go to the apply sort. So you can say sorting is partitioning is the technique to improve the system performance. That means whenever we have only one database server, okay, and you are storing a large database in only one table, that's maybe performance hit. Here you can tell, I am going to divide this one database in the multiple tables, multiple databases. Okay, multiple. This is only one server, only one instance, right now. So here you can managing, but still our system is not able to handle the user traffic which are very frequently accessing, and they are going to store more and more data that cannot manage by the one server. Then you can add one more and add one more. So here also we can apply the partitioning to use the effective data management technique. Here also you can use the partitioning effective data management. So you can say partitioning used for the individual shard level, and overall sharding means adding more and more server to meet the high user traffics, volumes of data. Because now our system is managing larger data set, and each data is storage. Whatever the database or data storage utility are internally make more efficient, more is resource cost, resource effectiveness. You can say use of effectiveness. We are apply the internally partitioning for each sharding. Okay, so sharding and partitioning are look like the same concept because they are the part of, because if are is the partitioning one and same are just horizontally scale out, it become a sharding. It is a it become a sharding. If you are doing the same thing on multiple database, multiple regions, that becomes sharding. The sharding and partitioning both are the look like a similar concept, but on the different node. You should aware. Partitioning means you are going to make your one specific database instance a server become a more performant, effective data management. But after some period of time, after some amount of data, some set of data, our system is meet performing. But after reach the size of the particular one server, even the after partitions cannot become a performant. So then we can go scale out. We can have this consider as a one shard, then again a shard, another database, different region, different location, and each shards our responsibility. We have to make effective use high performance system. Then again partitioning applied on each and every shard. So you can say shard is the horizontal partitioning, means different node or database server or data storage location you are going to use, and each data storage you can make the effective use high performance system. Partitioning help us to make the each shard become a very performant. So now hope this information help you to clear what the meaning of partitioning, what the meaning of the sharding. Okay, hope this information help you. Thank you.